Okay. Today we will discuss about array. Okay. So, have you any idea about regarding array? Anyone can tell me what is array?
Sir, array is a data type in which the memory location is continuous.
Okay.
And
Any
sir,
other?
it stores same type of element,
Okay. Same type of elements. And any other?
and it is linear and sequential.
Okay. Any other? Okay. So basically array means it is a sequential collection of element of same data type. Sequential collection of element of same data type. So anyone can tell me why we need array? Anyone?
Sir, it is easier to manage block of same data type rather than of different type altogether.
Okay. So why I want to show some simple example. So why we need array? Okay, just simple example. I'm showing you some. Is it visible now?
Yes, sir.
Okay.
Yes, sir.
Okay. Just imagine addition of two number. That is a most simple program. Okay. So just imagine integer a, b, and c. Then enter the values. Okay. And store the value in memory location. Two value %d, and one for a and one for b. So now c is equal to a plus b. This is a simple example. So display the result. Result is equal to %d is c. So run the program. So enter the values. Suppose we enter 10 and 20. Result is 30. It is a very easy program. Now think we need integer type value. So suppose we need one value more. So take c as a third value and d store the result. So here we need another %d, and here c, and now d is equal to c plus b plus c, and display the result. Now run the program. Enter the values. Suppose 10, 20, 30. Result will be 60. So it's okay. It is a simple program. But think if we want to store, so here we store only three values. Now, if we want to store 5 values, 6 values, it will be easy. Okay, we can store like that way. So A, B, C, D, E, F, G, like that way we can store that value. But think about this. Suppose we want to add 1,000 numbers of values, 10,000 numbers of values. So this will be very problematic at that time. So like that way, if we want to take in into input variable like A, B, C, D, or num1, num2, or A1, A2, A3, like that way, if we want to take 1,000 values, so it will be very difficult. So that is why we use array. Array means in single variable we can store the values. So that is the reason we use array. So this is the solution of that particular problem. So means suppose we want to add 1,000 element or 10,000 element. So it will be not possible like that way. Possible means it's possible, but it will be very difficult to assign A1, A2, A3 up to A 10,000. Then add all the elements. So it will be very difficult. Or it is not, we can say this is not a smart way. So that is why we use array. So how we can define array? So array we define like that way. So suppose A is an array. So we define like that way. Here we store the size of that array. 10 means we can A is an integer array. That's mean A store the integer values and maximum A can take 10 values. So suppose we assign 10 values, but we don't want to take 10 values. Suppose we want to take 6 values or 5 values. So that is why we take another n for define this, and we take another variables. And for some loop, we need some loop, no? So when we assign some array, so that's mean we need some loop. So that is I. Or for sum, we take sum 0. Suppose we want to add some elements into array. So first assign the enter the range. Range means how many elements we want to take. Suppose we want to take 5 values or 6 values, like that way. Now enter the all the values. In the list. So store that value, because suppose we want to take 5 values. So for that case, we want to store all the values in our memory location. So that's mean one by one. So it is not possible one by one. So that is why we use one loop. So I equals starting from 0, I less than n, and I plus plus. Then store that value. AI. So now it's okay. Now suppose we want to display that list. So take one printf, display the list. So at that time, for display purpose, we also required one loop. 0, I less than n, I plus plus. Printf %a I. And then suppose we want to add that value. So we also need one loop. I is equal to starting from 0, I less than n plus plus. Then we can say sum equals to sum plus ai. Then we can display that result. Result is equal to percent d sum. Now just run that program. So enter the range. Suppose we want to take 5 elements. So enter the values. Suppose 1, 2, 3, 4, and 5. So our list is like that: 1, 2, 3, 4, 5, and result is 15. 15 means 1 plus 2 plus 3 plus 4 plus 5. Okay, so that is the reason we use array, because at that time, so you can store more than 1,000 values, more than 10,000 values in between the list, and we can operate that value. We can use that value for our further process. So at that time, we no need to store individually. So that is why we use array. Okay. So look here, we can store that value in row wise or column wise. So that means 1, 2, 3, 4, 5 like that way, or just it is just, or we can store like 1, 2, 1 by 1. One is first position, let's say 2, then 3, means column wise. This is then row wise, and we can store the value in column wise. So that is why it's called one dimensional array. It is also the example of one dimensional array. Okay. So now next part is how we can represent multi-dimensional array. So first we check one thing, that is two-dimensional array. What is two-dimensional array? Basically two-dimensional array is the example of matrix. You know matrix? You know, I think you know the matrix. So how we can represent a matrix? That means some elements in that particular matrix are row-wise and some elements in a column-wise. So that is why row matrix is a two-dimensional array. So just check this thing. So in two-dimensional array, we need another boxes here. So first part, this part, suppose this part assign the values in row wise, and this part assign the value in column wise. And n means row number, suppose, and we take another variable n, and that is the column that represent the column. And I, one is called I is representing the row, and j is also representing the column. So now just enter the row size percentage address of n. Suppose n represent the row size. Now we need column size. Enter the column size. Put the value percentage address of m. Okay. So now enter all the values. So that's mean all the value means suppose row is 3 and column is 3, or row is 2 and column is 2. That's mean 2 into 2 or 3 into 3. So that's mean if 2 into 2, if our matrix size is 2 into 2, that's mean we need 4 elements. 3 into 3 means 9 elements. Enter the elements. So at that time we need to store that value in our memory location for row wise and column wise. So that is why we need one outer loop and one inner loop. So that is also called a nested of loop. So I is equal to 0, I less than n, I plus plus. This is the outer loop, and take one inner loop. Sorry, j is equal to 0, j less than m, j plus plus. Scan up the value, %d, address of a, I, and j. Okay, now display the result. For display, we need also one nested of loop. One outer loop, print the value. I and yeah. Here we need one line break. I'll discuss why I am taking this one. Now run the program. So enter the row size, suppose 3, and column is 3. So that's mean we need 9 elements. So take 1, 2, 3, 4, 5, 6, 7, 8, and 9. The list. So our list is like that. So this is called the two-dimensional array. Okay. So that is the procedure how we can represent a two-dimensional array. So now my question is, you know, why I use one backslash n in this line, why we use backslash n?
Sir, for
Anyone?
new line.
For new line. And
Sir, for new
here,
line.
new line. Okay. And for why we use this one, this printf? So it is not the part of that program. But after that, I use this thing, printf backslashes only. You know why we use this thing?
Sir, for new row. to come on the new row.
So if we don't use this thing, so then what happens?
Sir, all the row will be in a single line.
Yes. So that is why I use that line, and we use one space here. Look, we use one space here. So why we use that space?
For separating the elements.
Yes. So look, some gap is there between 1 and 2, between 2 and 3, 4 and 5. Okay. So that is why we use that thing. So this is an example of two-dimensional array. Okay. So now we're going to discuss another thing, that is already you have some idea about array. So after that we are going to discuss about searching problem, linear search. So you already know about what is linear search.
What is linear search, sir? Actually, I don't know.
Okay. So that is why I'm discussing that thing. Searching. First, think about the searching of an element. So why means how we can search an element from a list. That means suppose we have an array. Array means we can say it is a linear collection of data of same data type. So that is a sequential collection of data. That's mean array is a list. Suppose you have an array. That is the array. So 10, 45, 8, 2, 98, 33, and 11 in that particular array. But we want to search some element. Suppose we want to search 98. That means the 98 in his list or not, in that particular list or not. So that is why this is the main mechanism, searching mechanism, that is. So that means some element in that particular list present or not. So to searching that particular element, we have two procedures. One is linear search and another is binary search. So today we will discuss about linear search. Linear search basically what happens, suppose linear search is like that way. Mechanism is that. So suppose we have some elements is there. Suppose 10, 45, 8, 2. So 10 in the first position, 45 in the second position, 8 in the third position, like that way. We have here 7 elements is there. But we want to search 98. So in linear search algorithm, first we have to do one thing. First we check with the first element. So it is equal to 98 or not. So first check the first element with the first element. It is 98 or not. If not, then go to the next one and check again it is 98 or not. So if not match, then come the next one, next place, and match with the third one. If it is not matching, then come to the next one. So that is the procedure, and match with that value. If not matching, then come to next one. So when it's matched, it automatically stop. Stop mean we need one break statement. You know na why we use a break?
Yes.
Break. So break means if we want to stop some process in between. So at the time we use break. So that means this process is going on now. This process is going on from first element to last element. But before last element, we find on the element or searching element. So now that is break. That process will break. So that is the procedure of linear search algorithm. Mean check by one. So think about this thing. So that's mean it takes some times, na? If suppose 10,000 elements is there, or 1 lakh elements is there, 1 million elements is there. So that's mean at that time we need so much time to find out some elements. and all the elements are haphazardly it is means it not it randomly that is sorted, not sorted. So randomly that in every position, look, no rule is followed by any element. That's mean 10 in the first position, 45 in the second position. So that's mean randomly we can arrange that element and just search some element from that particular list. So it will take so much time. So how much time it will take? Just think about that. Suppose we have n number of elements. Suppose we have n number of element. So it will take, for best case. Best case means suppose we want to search for that particular list. For that particular list, we want to search. Our searching element is 10. Our searching element is 10. So in first step, we will find the element. Our searching element means 10 in first position. So at that time, it will take only 1 unit of time. Only 1 unit of time it will take. But if we want to search 11, this is a roast case, we say this is a roast case. If we want to search in 11, so it will take how much time? In number of time, because n means number of elements. That means 1, 2, 3, 4, 5, 6, 7. In this list, 7 elements is there. So that is why we need 7 unit of time. That's mean n number. We need n number of time to searching an element using linear search. So this is the roast case, and this is the best case, unit of time. But average means suppose for this case, in the middle, almost middle in the list. So average case, we need only n by 2 unit of time. Okay. Now check the C program. Okay. So first we need a list. Take a list. Then how many elements we want to take? Suppose n number of element. Then we need one for loop purpose. We need one variables, and then we need to one search. I mean, we need the searching element. We have to search some element. So that is why we take another variable search. Enter the range. Range means how many elements we want to take. %d address of n. Now enter the values. The elements. For store that element, we need one loop I starting from 0, I less than n, I plus plus. Scanf %d address of AI. Now display that list. We don't need to display, but we want to display for the example purpose. the list display purpose, we have to use one loop also. Okay, now search the list from that, search the element from that list. So enter the searching element. Send the address of search. Now apply the mechanism. So mechanism is I is equal to 0, I less than n, I plus plus. It's okay. Now apply the rule if ai equals to search we can say %d is present in the list in %d position. So first we need search and then we need I plus 1 and use one break statement. Then use one thing if search equals to n means all the elements. First search all the elements. Okay. We can say not search I means we need the position of that particular list. Yes. So print %d is not present in the list. So everything is okay. Not first run that program, then we will check. Okay. So enter the range. Suppose we want to take 5 elements. An element is suppose 4, 8, 1, 3, and 9. So our list is 4, 8, 1, 3, 9. Now we want to search, suppose 3. So look, 3 is present in the list in 4th position. Okay, 3 is present in the list in 4th position. It's okay now? Now run that same program if some elements is not in the list. Suppose you want to take 5 elements, okay. Then take 5, 8, 9, 4, and 3. Suppose we want to search 2. So 2 is not present in the list. So this is the example of C program code of linear search. So it is okay, but some other problem is we need we have to think about another problem also. So that is, if same number of elements is repeated in that list, that means suppose we have a list, and in that list some same number of same elements is there in 2 times or 3 times maybe. So at that time, how we have to apply this mechanism? So that's mean if some list, suppose elements 2 is repeating 2 times, so at that time we have to change some logic. Okay, so first check that thing. So at that time we need same program is there, but we take another thing that is called, suppose we count, initialize count, one variable is there, and initialize the count as 0. In same problem we repeat the same, but here we have in break position we continue one by one. That means maybe same elements may be in other places also. Then we change something. If count is equal to 0, that means if no number is found, so we can say percentage not in the list. Otherwise, we can say percent D is present, percent B times in the list. So one is search, another is count. Okay, just change these 2 lines and I run that program. So suppose take 6, we need 6 number of elements. So take 1, 8, 7, 7, repeat again, 6, and 7 again. Okay, now enter the searching element. Suppose we want to search 7. So look, 7 is present in the list in 3rd position. 7 is present in the list in 4th position, and 7 is present in the list in 6th position, and 7 is present 3 times in the list. just change something. Okay. Is it clear now?
Yes, sir.
Okay. Okay. So now again we want to move forward another topic, that is bubble shot. Today we'll discuss about also bubble shot. So shorting means, suppose we have oppositely arranged some elements is there in our list, in our array, and we have to shorted that list into ascending order or maybe descending order. So that is called the shorting. Means we have to sorted the elements in ascending order or maybe descending order. So here I show one example in ascending order how we can sort the elements. So many mechanisms there. So bubble shot is one of the most popular algorithm. So what is the mechanism of bubble shot? So check this thing. So our given list is like that. Suppose 5, first position 5, 1, 4, 2, and 8. So this is our given list. But in fast pass, first thing we have to do that we first compare first element with second element. We first compare first element with second element. And to check that first element or previous element is less than or greater than with the next element. If we found that first element or previous element is greater than second one, then we will swap the position. Is the mechanism. First compare with the two element. If first element or previous element is greater than the next element, then swap the position. So check here, 5 is greater than 1. So that is why swap after swapping. So 1 is come here and 5 is come here. So we start with first two element, then second and third. So then 5 and 4. So compare with these two, 5 and 4. So 5 is greater than 4. So that is why swap the position of that particular two values. So now look, 4 come here and 5 come here. Now in third line, again compare with this one and this one. And we can see that 5 is greater than 2. That's mean again swap the position of that two value. So 2 is come here and 5 is come here. Now compare with this one with this one. This two one. So now check this thing, 5 is less than 8. So that is why there will be no change. Means 5 remain the same place and 8 remain the same place. So look, after first pass, look, the highest value took his position. That's when highest value means 8, the highest value. So look, highest value in its position, mean last position, after first pass. Now we need another pass because it is not shorted. So we need another pass. So second pass is there. So again, repeat the same procedure. First compare with the first one and second one, these two one. So 1 is less than 4. That is why there will be no change. That means 1 and 4 will remain same position. Next step, we compare with 4 and 2. These two. But look, 4 is greater than 2. So that is why one swap we needed. So we need one swap. So just 2 come here and 4 come here. Now compare with third value with fourth value. Okay. So 4 is less than 5, so that is why there will be no change. 4 and 5. And here at the list, we have no need to compare with 5 and 8 because we know 8 is the largest value and already 8 in its position. Okay, so look, after second pass, what happened? After second pass, second value will be in its position. Second largest value will be in its position. Already 5 after first pass, already 5 is come, but it not always not happen. So after second pass, second largest value come to its position. Okay. So look, already this is sorted, but we have to check again. So just in third pass, compare with the first two value, no changes will be there. Then second and third, so no changes there. Then third and fourth. No need, we don't require this thing 4 and 5 because already 5 is already in its position. So that is the procedure. Okay, so that is the procedure. So look, after third pass, all the elements, or we can check this thing after second pass, all the elements in its position. So that is the mechanism of bowel sort. Now check this thing, how many times it will take to sort an element. So in base case means already sorted.
Array sorted.
Array sorted already. So suppose 1, for this case, 1, 4, 2, 4, 5, and 8. So for that case, we need how many times we require? Just compare with this one, compare with this one, compare with this one, and compare with this one. So we only need n number of times. We only need n number of times. Just go 1 to 2, 2 to 3, 3 to 4, like that way. For roast case, that means it is like that way. So 8 is in first position, then 5, then 4, then 2, then 1. For roast case, it will take how much time? So first, after first pass, 8 will come to its position. Check. First compare with these two, 8 will come here, then 8 and 4, then 8 and 2, then 8 and 1. So after first pass, 8 will come its position. After second pass, 5 will come its position. After third pass, 4 will come its position. So like that way, it will take maximum time. So how much time it will take? So we need, for that case, we need only, at that time, we need only one pass. But at that time, we need how many pass? N pass. So n into n, that means it will be take n square. N square time we require. Okay.
Sir, sir, why isn't it n minus 1? Because in first part, when the array is sorted, we are doing 4 iterations, 4 processes in while sorting.
So we have to check again now. So just it is take n minus 1, but we always, when you taught the subject algorithm, when it's come to defining the time complexity, n minus 1 means we can take n. Okay. It will take n times. So let's check the C program for that particular problem. So take one list and take range of that particular list. Then take one outer loop, I for outer loop, J for inner loop. Why we need this thing? That's mean I represent the position. not the value, position, first position, second position, third position. But J represent the number of value, means value 5, 4, 8. So we need two loop. One for the position and another for the value. And then we need one variable swap. So again, enter the range. So range is %B, address of n. So now enter all the elements. To store this thing, we need one loop starting from 0 and is in plus plus. Scan the value, put the value. Now we can display the result. So that's when we don't need to display, but for just example purpose. Display the given list. Now apply the logic. So first, for I starting from 0 is the name, but we don't want to go the last element. Huh? Okay, we always compare with the position. So that is why we need n minus 1, n plus plus. Then we require another loop for the values. So that is j is starting from 0, j less than n minus I minus 1, j plus plus. And we can say swap aj a oh no, sorry, we need to first we have to compare something, otherwise it's not possible. Now if a j greater than a g plus 1, but compare these two positions, then start this thing. If AG greater than AG plus G plus 1 means next value, then swap AJ and AJ will be A G plus 1 and A G plus 1 will be swap. So that is the logic. Okay. Now display the result. At least for loop for I equal to 0, I is the name I plus plus printf and D I. Just check one time. Then so enter the range. Suppose you want to take 5 elements. So enter the values. Suppose 5, 9, 4, 2, 7. So display the given list. So our given list is 5, 9, 4, 2, 7. But after sorted, 2, 4, 5, 7, 9. So it is clear now. So check these two things.
Yes.
Now check these two things. I hope I expect some questions from this side. This side means why we take n minus 1 and why we take n minus I minus 1. I expecting this thing from your side. Just check one time. In first case, we compare with, look, we want to go before the last element. That means here to here, here to here, here to here, and here to here. So just we compare with before the end of the list. And when after first pass, when next pass will come, we will go up to, so that means last element already sorted. Now after first pass, always last element already sorted. So we have no need to check again. We can check, but we don't need to do this because it already sorted. So that is why we use this thing, n minus I plus I minus I 1. Okay, so check your assignment section. Already some assignment 2 is uploaded, and just try to solve this. Okay, so assignment 2 is basically depend on the previous day. Ram sir gave you some information regarding point to pointer, point to structure. So regarding these issues, so just try to solve that thing. Okay, assignment 2. So if you have any doubt, you can ask me. Otherwise, you can be on offline, or you can try to solve this thing.
Sir, when will the lab be offline?
So, one notice is there, so I hope from 29 maybe, but I am sure it will start from 29 as you know, but I'm not sure. Okay, you will get some notification. You will get some notification from the institute.
Okay, sir. Okay.
Okay.
Thank you, sir. Can we leave, sir?
Oh, Yes, you can leave.
Thank you, sir.
Thank you, sir.